got a silver nickel voltaic cell, and it's made under standard conditions. It's a voltaic cell, so it's the two half reactions. Give the reduction half reaction, and they're going to ask us all of those questions, so we're going to need a redox table. So we've got the nickel and we've got the silver marked over there, and obviously we're going to have to write the nickel backwards and we're going to have to write the silver forwards if it's going to be spontaneous. So the first thing is, what is the reduction half reaction? The reduction half reaction is going to be silver, so we're writing that one forwards, plus an electron, gaining electrons gives me silver metal. Write down the half reaction that occurs at the anode. The anode is always the oxidation, so the oxidation is going to be nickel becomes nickel 2 plus 2 electrons. It's important that we have these looking, that all the little charges are in the right places and all of that sort of thing. So you must put a 2 plus there, you must put a minus on that electron. Remember, now that we've decided what is oxidation and reduction, we're only going to write one-way arrows over there. Which electrode increases in mass when the cell is used? Well, I'm making more and more silver solid, so the silver electrode is going to increase in mass. Give the cell notation for this particular cell. We always write the anode first and the cathode afterwards, so it's going to be nickel to nickel 2 plus, Saltbridge silver plus to silver. And I can also put 1 mole per cubic decimeter or aqueuses and solids and things like that, but don't have to for the exam. So you can keep it simple if you want to. What is the EMF of the cell? Well, since I wrote the silver backwards, since I wrote the nickel backwards, I'm going to change that sign over there to plus 0,25. And then the silver I wrote forward, so I'm going to keep the sign the same, plus 0,80. And then when I add those two together, I get 501, so it's 1,05 volts. Answer the following questions about the chloralkali industry. Which type of cell is most commonly used to produce chlorine gas? And nowadays we land up using the membrane cell. That's the one with the semi-permeable membrane that only lets cations across it. Why is it preferred above the other two cells? Because it's more efficient. So in other words, it uses less electricity. That's its first good deed. And its second one is you get 32% pure sodium hydroxide out of it, which is purer than the other ones give us. They give, I think, about 12% and something even less than that for mercury. Give the two half reactions that occur in the cell as well as the net reaction. So the first thing that's going to happen is, remember, it's the hydroxide ion that gets affected first before the sodium. Now you may think that when you've got NaCl that you're going to look for the sodium half cell and the chlorine half cell. Well, you do look for the chlorine half cell, so that's good news. And you look for the sodium half cell, but remember that this is all dissolved in water. And it turns out that water is going to be reduced more easily than the sodium, because remember, this is non-spontaneous, so the chlorine is going to go backwards and the water is going to go forwards. And because the water is more easily is more easily reduced, it's lower down over here, it's more likely to be reduced than the sodium. This is the half reaction that's going to land up taking place. Turns out the sodium ion lands up just being a spectator in this particular sport. So we're going to go 2 Cl minuses becomes chlorine plus 2 electrons. Simultaneously, the water, 2 waters plus 2 electrons, don't forget your little minus signs on the electrons, becomes hydrogen and 2 hydroxide ions. The electrons then cancel, and I land up with 2 Cl minuses plus 2 waters gives me Cl2 plus hydrogen is given off in the cell and hydroxide ions are given off. And then if you think about it, the sodium is just a spectator over here and it is a spectator over there. So you get sodium hydroxide and you start with sodium chloride, but the actual electronic reaction that's going on is given by that reaction over there. Answer the following questions about batteries. Correct the following statement. The purpose of a battery or cell is to provide charges to the circuit. It doesn't. It provides a potential difference, an EMF or a potential difference. That then causes the charges to move. So it's not, they don't provide the charges. What is the difference between a primary and a secondary battery? A primary battery can't be recharged, whilst a secondary battery can be recharged. A battery is transferring energy of 3,000 joules with a current of 5 amps in 30 minutes. What is the charge flowing through that battery? Well, from electricity, you know that Q is equal to IT, and that is going to be equal to 5, because that is your current, times a time of 30 times 60. So that charge works out to be 9,000 coulombs. What is the battery's capacity in amp hours? Now, this idea of battery capacity is really not difficult. It's amps times hours. So it's 5 times half an hour. So it is always the amps times the hours, and you land up with 2,5 amp hours. What is the EMF of this particular battery? Well, we do know that potential difference is equal to work done divided by charge. They've told me the work done, in other words, the energy transferred, it's 3,000. We've got the charge, it's 9,000, and I land up with 0,33 volts. Explain why it's so important not to dump used batteries and say how you could dispose of them. You here need to go into the fact that there are poisonous substances and heavy metals and that are used inside batteries, and these can't seep into the groundwater from dumps, so they must be recycled. You're given 2 half cells over here of an acid solution to set up an electrochemical cell. The cell operates under standard conditions. Give the cell conditions that apply to this electrochemical cell. So we've got lead and we have got oxygen and hydrogen over here. So we need to go to the information sheet. We found the 2 half reactions that we are looking for, which is the lead 2 plus, and the oxygen and the water. And you set up the electrochemical cell. They say it's in an acid solution, which makes sense when you look at this half reaction, which needs some H pluses hanging around. Give the standard conditions that apply to this particular cell. Well, we're bringing a gas in here for first time in a long time, so you're going to need to refer to the pressure of the gas. The pressure of the gas is going to be 1 atmosphere of pressure on the oxygen. 25 degrees centigrade for everybody. Then your concentrations, 1 molar or 1 mole per cubic decimeter of lead 2 plus, and 1 molar concentration of H plus. So those are your standard conditions over there. Which half cell represents the anode? Anode is always where oxidation takes place, so it's the one that we've written backwards. So it's going to be the lead over here, so that is your oxidation. And give the equation of the oxidation half reaction, it's done. Give the equation for the reduction half reaction, done. And remember one-way arrows, because we now only, we've decided it is oxidation, it is reduction. So now we need the overall balanced equation. So because of these 4 electrons over here, I need to go 2, 2, 4, cancel the 4 electrons, 2 leads, plus oxygen, plus hydrogen, gives us 2 lead 2 pluses, plus 2 H2Os. And now we've got that as a balanced equation. And calculate the EMF of the cell. I wrote the lead backwards, so that's going to be positive 0,13. I've written the oxygen forwards, so that's going to be positive 1,23. Sorry, that's 1,23. It's a bit of a big comma. And when I add those two together, I get 1,36 volts. following half reactions occur in a nickel-cadmium battery. Given to us, which electrode is going to be the anode and which one is going to be the cathode. Well, I can quite clearly see it's a battery. It's going to produce energy. So I'm going to need to, this one's higher up on the table. If it was on the table, it's not on the table, but it's very negative compared to this one over here, which is very positive. So what I'm going to do is I'm going to say I would have to write that one backwards, which means that it's going to be the anode. So the anode is going to be the cadmium half cell. Write down the equation for the oxidation half reaction for the cell. So I now just need to write this cadmium story backwards. So it's going to be Cd plus 2OH minus. Choose the arrow now. It's a forwards arrow because I've decided that it is oxidation and 2 electrons. Write down the balanced equation for the reaction that takes place when the cell is in operation. So I now need to write down all of this stuff about the nickel half cell. And this one I'm writing forwards, so I decide on my direction of my arrow. And then I can see that I have got 2 electrons over here, and I've only got 1 electron here. So that needs to be 2, which means I need to double that up, double that up, double that up, and double that up. I can now cancel the OH minuses on both sides and the electrons on both sides, leaving me with Cd plus 2 NiOOH plus 4 H2Os. Oh, sorry, I'm lying. I don't know where I got an extra H2O from over here. Sorry, that's just a 2. 2 H2Os. And you then get CdOH2, cadmium hydroxide, and nickel hydroxide. And that just doesn't fit in, but there you go. Calculate the EMF of the cell. Well, I had to write the anode backwards, so it is going to be positive 0,82. The cathode I wrote forward, so it's 0,48. And when I add those two together, I get 1,30 volts. In which direction do electrons flow when the cell is being recharged, not discharged? In other words, it has to be the exact opposite of what I've just done over here. So over here I've got electrons flowing. I've written that one backwards, so I've lost electrons. So the electrons were going from cadmium and nickel was gaining them. So if I'm recharging it, I'm going to go from nickel to cadmium, in other words, the other way around. And list the main features of a NiCad battery. The best thing about a NiCad battery is that it is a rechargeable battery. Answer the following questions on the Hall-Héroult process for producing aluminium. Firstly, what is bauxite? It is aluminium oxide ore. What is the purpose of adding the cryolite and how does it help in the economics of the process? It lowers the melting point of bauxite, therefore less electricity and therefore less cost. Copy and complete the equations for the reactions occurring at the anode and at the cathode. Also write the next net reaction. So these are on the information sheet, and you're going to take the 2 O2 minuses, sorry, that should be a superscript, and it's going to become O2 plus 4 electrons, and over here we've got aluminium 3 plus 3 electrons becomes aluminium. And then I need to multiply that whole line by 3 and that whole line by 4. And let's just do that quickly. So we'll end up with 6, 3, 12, 12, 4, 4. And what comes out the other side is 6 O2 minus plus 4 Al3 pluses gives me 3 O2s plus 4 A else. And if you want to make that even neater, there's positive ions and negative ions, so it turns out to be 3Al2O3 because the aluminium's got a valency of 3 and the oxygen's got a valency of 2. The anodes have to be replaced from time to time. What is the reason for this? And give a balanced equation to explain your answer? Well, it's a carbon anode, and it is reacting at all times with this oxygen. So plus carbon, you make CO2, and therefore the carbon of the anode keeps corroding away or going off as carbon dioxide. Articles made of aluminium, such as cool drink cans and waste window frames. I don't think that should be waste, but anyway, window frames are recycled to obtain waste when you're done with them, are recycled to obtain the aluminium by smelting. State 2 advantages of recycling the aluminium. Firstly, you use less electricity, so it's less cost. But even more important than that is it's less CO2 emissions. And last question, lead acid batteries can be recycled. Battery manufacturers use innovative methods to convince customers to hand in their car's expired batteries when they purchase a new one. Explain why it is profitable and in the interest of the environment to recycle lead batteries. Well, firstly, you don't have to get any more lead raw materials, so they can be reused, and lead does not leach into groundwater, and lead is a heavy metal, and therefore heavy metal poisoning prevented.